Okay, Professor Erika Schagatay, welcome back to the Freedive Café. It's been 5 years, I think, 5 or 6 years.
Sounds a long time.
It sounds a long time. It's surprising, huh? But really nice to have you back on our first episode, which, despite the poor audio quality, was very. It was a little bit exciting because I think that was the first time that you really had like a sort of in-depth discussion on things like the dive response in that media format for the freediving community, and so that was episode 42. So if someone wants to go back and listen to it, they can check it out on the Spotify. And because of the audio quality, we also had a full transcript of that one as well, which you can read on the website, freedivecafe.com or freediveandthrive.com. So we are, first of all, before I start, I want to give a shout out to two people. First of all, Nathan McClatchey, who saved my ass today because he let me borrow a screen for the laptop because I destroyed the screen on my laptop. So thank you very much, Nathan. And also a big shout out to Chou, who is visiting from Barcelona with Mireia, who's a big supporter of the podcast and is over here doing a bit of training right now. So I told you I'd give you a shout out, Chou. So there you go. Okay, Erika, we're in the Divelab. Tell us about the Divelab in Dahab.
We started building it 2 years ago to be able to test a lot of divers because Dahab is one of the best places, of course, in the world to find training divers. You've
been coming here. You'll come here a few times a year, and you'll conduct some research. And you were just doing some tests yesterday. You were telling me about the ramp test that you've been developing for apnea, this apnea ramp test.
Yes.
So I'm familiar with the ramp test in terms of a kind of a graded exercise test, like maybe like a VO2 max test, similar kind of idea to test the upper aerobic threshold in runners and cyclists and things like that. So what is an apnea ramp test, and what are you going to use this data for? What is the goal of the research?
Well, in most of the sports where many people are involved, they have standardized tests to see where you are at your performance cycle. And then you can train what you see is missing. And in breath hold diving, there is no such test, so we are trying to develop one.
So what does a test look like? If I was to come and do a test tomorrow, what kind of thing would you make me go through? Because some of the ramp tests that I'm familiar with are quite challenging tests. Is the apnea ramp test also quite challenging?
Well, it can be challenging for beginner divers because they have to hold the breath for 1 minute, rest for 2 minutes, hold the breath for 2 minutes, rest 2, and then hold the breath for 3 minutes. And we measure a lot of very important variables like the diving response, some things that have to do with the blood. And we can see and compare between different individuals and also between the same individual at different occasions how well you are performing. Mm-hmm. Because the time is limited, you can really see the oxygen cost for a 3-minute apnea, for instance, for a beginner or for a very qualified diver.
So what have been the, obviously you haven't finished the research yet, but what kind of results have you had from doing these tests so far? Like, what are you seeing?
The first thing we have seen is we have tested about 100 divers now here in Dahab, and we have been able to divide them in 3 groups and see who is very fast desaturating and who is very sustainable. So there are some people that after 3 minutes of apnea, they don't desaturate at all. So even if they don't breathe, they don't have any visible effect of that. That means they have huge oxygen stores or very, very low metabolic rate. And also we can predict a little bit who is sensitive to a severe hypoxia, and this is one of the aims of our studies, to see who is at risk for blackout, especially among beginners.
So if you see someone becoming desaturated very quickly, you think they may have a higher risk for blackout as they continue in their journey in freediving. Let's say they're a beginner and they would do this test, and then you can see, okay, maybe this person is going to have a higher risk of hypoxia sooner than a person who is showing really high saturation after 3 minutes.
Yeah, that is true. And one of our aims, and also one of our main sponsors, is interested in preventing blackout deaths. And that is mainly happening in beginner and recreational freedivers, not in competition divers. So we are very concerned to see what is the individual limit and how should you plan your diving. And if we can have a standardized test, then you can also preset your kind of diving pacing strategy. Because recreational freedivers, they do repeated diving.
Yeah. As a coach for divers, especially some people who are halfway across the world as well, it would be quite. I do baseline tests anyway, like for people's mobility, for their strength capacity, and then obviously I get their personal bests and things like that. But this kind of test would be like a really nice thing to know the results, to set somebody up on their next kind of coaching block, I would say, or even their first coaching block.
Yeah. And I think also even for elite divers, it could be useful to know which factors are optimal already and which factors are maybe lagging behind, that you should train, I don't know, CO2 tolerance or hypoxia tolerance, or you should train your spleen, or you should train your diving response. And we know pretty much about how to train these things. But if you make an overview of what you need to be even better as a competition diver, you could also use this test.
Okay. All right. So fascinating. And then, so you're testing. You're testing complete beginners.
Yeah.
As well as trained free divers.
All the range in between.
And you're seeing that some people are all the trained free divers, do they all have really good tolerance to hypoxia, or do you see completely untrained people with really good tolerance and trained people with really low tolerance?
It's a good question, and actually what we have seen in a lot of research through the years is that everything comes both through genetics and through training. So there are some cases of pure beginners that have a very high oxygen reserve, they have a high tolerance to hypoxia, and they have a ability to lower their metabolic rate. Is that these three things that make you a good diver. And among trained people, it is harder to see the difference, but of course, when you look at the really top people, they have all these things at the top level. But then you still can't know if they started, because you were only doing these tests now, so you don't know if they started with this advantage or whether this advantage was trained over the years, right? With some of the elite divers today, I have studied them also 20 years ago, so I actually know a little bit about it. I haven't published it. Yeah, I remember I was in Gili Islands. I know that the next day I had to go and do a requirement for my instructor course, but I passed by like a bar on the way home to have an early night's sleep, and I heard the music, and I'll go and see what's happening in there. And I went in and met this bunch of people and started socializing with them, and they asked what I was doing, and I was like, I'm doing a instructor course freediving. And then I had them all, we're all drunk, so got everyone to start holding their breaths, not in the water, fortunately. But there was one guy there. He just sat down. He took a breath, and he just held his breath for 4 minutes, sitting there right in front of me, like without any discomfort whatsoever. And the guy had never done any apnea or breath holding before. So, yeah. I have the same experience, and I, for instance, tested some of the best skiers in Sweden. Sweden is kind of a skiing nation, not a diving nation so much. But some of the really best skiers, they could also hold the breath for 4 minutes, which is interesting, because they can tolerate discomfort to some extent. So you will continue doing the testing over at what point do you reach a conclusion? When will there be a ramp test that we can all use? Right now we are analyzing the 100 divers that we have measured. And it's about 60% men, like 60 men and 40 women, and I will probably come back in the fall to try to do another 20 or 30 women, because I also want to know if there is a difference. We don't see a difference at this point, but there could be things that we want to know about gender differences. But we're also developing a dynamic apnea ramp test. And that is what we are just beginning to doing now. That's why I'm in Dahab now, to do a test that is swimming one lap in a 25-meter pool, and 2 laps and 3 and 4, which is 100 meters, with 5 minutes resting in between. And we are measuring a few different things, including lactate, which is a typical variable that you measure in this kind of performance tests in other sports.
Yeah, that would be especially important in the dynamic disciplines, right? This ability to clear lactate through the course of a long dive.
Well, at least to not use your anaerobic capacity too early on. So there is something called the lactate threshold. It's very often used to describe marine mammals' performances. And they can use their aerobic capacity for short dives to do a lot of repeated dives. But if they want to do one single exploratory dive, they have to also tag their anaerobic capacity. And the anaerobic capacity of humans in breath hold diving is not known. So that is one of the goals, also to understand better what is the kind of
it's fascinating
anaerobic level.
Because I follow some like triathlon stuff. I follow those guys. The difference between a runner. The difference between somebody that can run like a 2.5-hour marathon compared to a 4-hour marathon is that these people, when they're running, at your sprinting speed, are still not, crossing over that threshold, building up lactate yet. So could the implications there be that that same kind of training that they are doing for anaerobic, for aerobic training, for long distance aerobic efforts, for example, that it could feed into freediving training too?
I think running is good. I think aerobic exercise is good. I think anaerobic training is good. But I think there are also differences with freediving and aerobic stuff. Okay,
so recently we had a really interesting article with Frank Pernett, who is soon going to defend his thesis. He's a PhD candidate, and he has his thesis is titled "Hypoxic Blackout in Serial Freediving: Protective Mechanisms and Risk Factors." I have read the abstract. And I have a few questions about it, but perhaps you can tell us exactly what Frank's work is all about.
Well, the task that he set out to answer was, why is it so common among recreational freedivers to blackout and some of them drown? So he's decided to study serial freediving, not like maximal performance freediving, but when you do repeated diving, also like spearfishers.
Spearfishing, fun diving,
snorkelers,
underwater photography, that kind of thing. Yeah.
And one of the factors that has been known for some time to be a risk factor is hyperventilation. But then you think of hyperventilation like really consciously overventilating before you do maybe a maximal performance. But what he has found is that it is very, very important not to hyperventilate also when you do serial diving. And even a very small period of a few breaths of overventilation will lead to accumulation of an oxygen depth in your tissues. And that means you will desaturate much faster in the second or third and fourth and fifth dive. And this also happens unconsciously.
Okay, this is very fascinating information, because when I think of an oxygen debt, okay, first thing is I'm thinking of, let's say, we do a maximum effort, anaerobic effort, like a sprint. Let's say we're going to run up a hill at full speed, and of course we are able to tap directly into our ATP to produce that effort. So we kind of bypass the oxygen system, the glucose system, whatever, and we have that maximal effort. But when we get to the end of the run, we're going to have to stop and we have to pay off this oxygen debt that we have, right? So this is, I'm thinking right here, right? So then if I think, okay, how can we accumulate an oxygen debt if we're doing such easy dives where we don't feel this kind of need to compensate at the end of the dive if we just do an easy 10-meter dive and come back up? What is it about hyperventilation that makes the difference?
Well, even if you just hyperventilate very, very little, you can extend your dive time to a little bit into the anaerobic phase. And that means that you accumulate lactate. And lactate, you have to use oxygen when you come back to the surface to process it. So I know this because I have been also trying to follow the AMA divers of Japan, and they dive for 4 hours straight in the morning, and they spend about 50% of the time underwater. And they do dives of 40 seconds, which sounds like a ridiculous short time, but they also manage to rest only 40 seconds, and then they go down again. And this, to me, when I was following them, was kind of easy for 5, 6, 7 dives, but after 10 dives, I was exhausted. I had to spend 10 minutes on the surface. And that was because I was always tagging a little bit the anaerobic system to do what they were doing professionally within their aerobic diving limit. And this is so interesting because how do they know exactly when to surface again to not tag the anaerobic system?
So it comes back again to this ability to clear lactate.
Yeah, to clear lactate is very important, but it's even more important to not create any lactate, to keep within your aerobic diving limit, like most marine mammals do when they forage dives. When they forage dive.
In this context of serial diving, lots of shallower dives over a longer period of time. So it seems then that deep diving, the maximal effort dives that we do, where they're basically easy then, right? You know what you do.
Well, then you can rest all you want.
You
after.
can rest all you want. You rest
can
the whole
put
day if you
everything
want.
on one card, and you don't have to rest for the. You don't have to dive for the rest of the day or the week.
Yeah.
But the AMA divers and the Bajo divers, they have to be able to dive again very soon, and the only thing that matters for them is the bottom time. And then it's much smarter to make very short dives and to have very, very short recovery time.
So I wonder then, if we're doing very deep dives, but we're still doing a session that includes several dives. We might have some warm-up dives, we might have 1 or 2 warm-ups, we might have a maximal effort dive, and then at the end of the session we might have some shallow or technical dives, drills or something like that. It might be a typical session for somebody who's maybe not peaking just before a competition, but somewhere in the middle of their training. Then it's also something to consider then that the rest times between the dive is not just nitrogen related, that we need time to clear nitrogen, but also that this could be a factor
related to lactate. Absolutely, yes.
Yeah, because I have heard it's quite common to hear recently around here that there, people are sort of incorporating hyperventilation into their diving and deep diving as well, and sort of promoting that a little bit as a technique that can be used by people to increase their comfort and things like that. And
well, 20 years ago, everyone was hyperventilating like crazy before competition dives. But people have figured out that it has a downside to it. And that is, if you hyperventilate too much, you don't oxygenate your brain very efficiently. And you actually need the high CO2 in the end of the dive to stay awake, because that opens your vessels to your brain.
Yeah.
And most people know that now, but 20 years ago nobody knew it, and everyone was completely into hyperventilating, and they even black out from hyperventilating.
Yeah, I think a lot of people still have in their mind that CO2 is a waste product, and I tend to tell my students that it's not really a waste product. Of course, we need to get it out, but we also need to have the perfect amount of CO2 in the system to maintain this homeostasis in the blood, this pH balance that leads to the right uptake of oxygen, right?
Yeah.
Actually, there was a question from one of the patrons. Maybe now is a good time to bring it in, because so this is from Tom Way. Thank you for the question. He was asking, does anyone know if there is a pH level or a level of CO2 in the blood that is optimal for availability of oxygen? Is it just our normal breathing, our tidal breathing is doing that? Or would a little bit more CO2 be more optimal?
I would definitely say the normal one when you are resting and breathing.
Yeah.
I would bet on that.
Yeah.
Not that I have done comparative studies, but I think that would be evolutionary a good answer, that we are getting that when we don't over or under ventilate.
Yeah, a few billion years of evolution, so that did a good job. And I think another thing that was interesting, one of the notes that I took from Frank's thesis, was that it was hyperventilation was also observed often in those divers who were trying to avoid it.
Yes.
Meaning it's quite easy to hyperventilate by mistake, right?
Yeah, that's true. And when you do serial diving, as recreational divers and snorkelers usually do, you will hyperventilate without noticing. And that means if you make very many dives in a row, you should take a little bit longer break, just on the surface, just relaxing, laying on your back, breathing. So maybe when you have done 5 dives, you should take a 5-minute surface break.
Mm-hmm.
And that would prevent, we think, a lot of these accidents that we see today.
All right, so did you have anything else you wanted to add about Frank's stuff?
Well, he's also shown that we can detect hyperventilation by using a chest strap. And beginner divers, if they would use that, they would have a kind of warning that now you should take a longer break, and now you're hyperventilating, that it could be a risk. Of course, they should also really learn how to have a proper safety. But I mean, when competition divers always know about safety, and trained divers from diving schools, a lot of recreational divers, they don't even understand that. And the first advice would be to go to a diving school to learn about safety systems. But there could also be a technical device, for instance, a dive computer that says, okay, now stop for 5 minutes. And then they start again. And then even if they have involuntary hyperventilation, after 5 dives, okay, take a 5 minutes break. This is something we are considering, and this is something that our sponsors are very interested in, to make a diving computer that is also good for recreational divers.
How does this work with the chest strap? What exactly is being measured with this strap?
We first tried to measure CO2 in your exhale air, which would be the ideal version to determine if you hyperventilate or not.
Convenient.
Not so convenient in water, because you have to carry. We thought we would put it in the snorkel, but many freedivers don't use even snorkel. But then we said that, what if you can pick it up from just this chest circumference? And Frank has developed a system to compare that. We did it first in the lab and then in the field lab, to see how your breathing movements correspond with your CO2 levels. And if you have a baseline for an individual, you can easily see when they overventilate. And then you can see if that is really correlating well with your CO2 levels. And he found that it does. That's also in his thesis. So that could be the basis for developing a safety system, maybe a very easy to put on string that will say, beep, beep, take a 5 minute break, because you're accumulating an oxygen debt.
Fascinating. Okay. Tell us about the research that you were doing with the deep dives, with the pulse oximetry at depth.
For very many years, we have done a lot of research with pulse oximetry, which is measuring heart rate and saturation. But the problem was there is no underwater version of this thing. So I've been sitting on platforms in world championships, and when people come up and they do their protocol and they are okay, and then I wipe the hand and I put it on, and then if I'm lucky I get the nadir value. If they have been to 100 meters, it will be maybe 80% or. But now through contacts with underwater technology professor, we have developed an underwater pulse oximeter. And it's not just to case a normal pulse oximeter and put it underwater, but you have to start from the really beginning with the interface being water. And we have a reflective monitor now that is measuring on your forehead instead of on your finger. And we have succeeded now to measure oxygen saturation in your blood down to around 100 meters. And this is very, very rewarding because we can compare all the results to what we have done by simulating dives in the lab. When you do a lab measurement, you have the ideal condition for measuring stuff, but you have to mimic a real dive. And now we can actually send the device down, mounted on the diver. So they have a small sensor on the forehead, they have a cable through the hood in the neck, and this cable is just transporting all the information to the small logger, and when they come up we can see what happened across the whole dive.
So the saturation information is still coming from the finger?
No, it's coming from your forehead.
The forehead. Okay, so what kind of conclusions have you reached then from finally having this ability to do the pulse oximetry at depth?
Well, one of the things we wanted to know was that if a diver goes down to a deeper depth, they will be first of all hyperoxic, because when the air is compressed, also the oxygen pressure will be higher. So actually when you deep dive, you will take up more oxygen from your lung supply than you can on the surface, which is good. But then when you start ascending, it will be the reverse situation, that then suddenly your partial pressure of oxygen will go down, and then suddenly you can even have the reverse flow from your blood back to your lungs of the oxygen, and that means you are rid of oxygen in your brain. And this is known since the 60s or even before. But we could see that some divers, they start desaturating already when they are going down and when they are at depth. And this is very peculiar because this is when they should really saturate the blood that is going to the brain with oxygen. And this is indicating that some divers, they have a compromised gas exchange in the lungs when they are at depth. And this can be caused by at least two different factors. It could be that you have lung atelectasis, that some of the lung is collapsing, the alveoli are not working anymore. Or it could be by pulmonary edema, that is the swelling of the lung, that it doesn't have any gas exchange anymore. And this is likely partial, but these divers, they come up with a very low saturation level, and they are also at risk for blackout.
And that point about the and I'm going to have to because the atelectasis.
I don't know how to pronounce it.
Yeah, it's a very tricky word. But this is the atelectasis is this the lung collapses in some areas.
Yes.
And there are a few reasons why that would happen. But when it collapses, then it can no longer the gas exchange can no longer take place. And we discussed when we spoke a couple of days ago that there could be some kind of genetic variation in people that makes this desaturation more possible, but also that the injury or the edema, pulmonary edema or barotrauma could be more common in these divers, correct?
It could be that some type of lungs are sensitive to compression in that way, and some others are not. And it's quite well known that some people, they squeeze easily, and some people, they can go to either depth and they don't squeeze. And there are a lot of other factors that affect, of course, the actual depth where you squeeze. It's a lot of with stretching and training and so on. But also with lung diseases, it's known that you have different kinds of varieties of lungs genetically. So it's not only about training. It could be that people come in two or even more varieties, some that are susceptible to squeeze and some that are not.
And you also mentioned that what you see is that in these very deep dives and elite divers that the dive response, I think you said, is getting weaker.
Well, it was thought before from laboratory studies that when you go deeper, your diving response kicks in even more, and it would kind of balance the effect of going deeper and the exertion level and so on. But what we found was that you get less of a diving response when you go deep. So it's just adding to the problem that you don't have a protective diving response, and this is because you have to put more effort, especially when going up again in deep diving. First of all, of course, when you swim against buoyancy, when you go down and then you free fall. But when you turn, you have to put so much effort that you compromise your diving response. And that is adding on to the problem of gas exchange that has to do with the partial pressure of oxygen changing so much. The problem with deep diving is multifactorial. It's not only the gas exchange problem, it's also that you don't have the same protection as you have with shallow, and what we mean with shallow is like 20-meter diving.
When you said that you measured that on the descent, you already see some of these deep divers desaturating. Was that a surprise to them that they were desaturating so early?
Good question. I don't think we discussed it with them, but they know they have a problem sometimes with the risk of blackout or samba. So probably they will say that they were aware of it, but they wouldn't be aware of the cause of it. Because most people, they saturate even better when they are in the beginning of the dive, when they are down at their maximal depth. It's only when they come up that they desaturate.
Fascinating.
From Erik's studies, we also found that there is a separate cause of blackout that we didn't think of before, and that is arrhythmia.
Okay, yes, I do have a note here to cover this, yes.
Yeah.
That it's not just pure hypoxia that can lead to blackout.
Yeah,
but
because when you talk about hypoxia, you usually think of your brain being too hypoxic and then it kind of closes down. But if your heart is sensitive to hypoxia, it can be compromised. The pumping function from the heart can be compromised before the brain shuts down. But when the heart doesn't work properly, you will have a drop in your blood pressure, and then the brain will shut down. So that could explain why people black out despite having the same saturation. Some people black out, many people don't black out. And this is one other individual factor that we think can be crucial when it comes to who is blacking out.
Microphone.
Should I say it again?
Having a bad day, this microphone. That then also makes me think about blood pressure and how blood pressure affects our free diving. Do you have any thoughts on that? If someone is has a low blood pressure or a high blood pressure, is it affecting this ability to saturate? What changes?
Well, blood pressure has to be regulated within a special range for you to perform in any kind of sport. And I think it's important in free diving as well. If you have a very high blood pressure, it could be straining when you hold your breath, especially in static. If you have a high blood pressure, it could be straining in static, because in static we know that blood pressure is increasing a lot. And in deep diving we don't actually know so much, because most of the studies are done in the laboratory, where you simulate deep diving, which you don't do very well in lab. This is also something we hope to look more into with wearable technology.
Yeah, I test my blood pressure at home, not every day, but most days. I have one of these little things I sit on the table, because I noticed that it's quite a lot of variation, from day to day in my blood pressure. It could be quite low and healthy, and then on some days, and it can be, I'm testing, in the morning when I'm rested, so it's usually quite, similar conditions each day, but then it can also be outside of the healthy range on some days for no apparent reason. So it might be cause, if we know more about that, to also have to be checking more regularly our blood pressure, and that could inform a little bit what we do on a training session, for example.
It could be. Yeah. It could very well be. But if everything, of course, when you go into the water from air, everything that has to do with blood pressure changes. This is important to realize. So even your baseline changes when you go just immersed to the neck.
Mm. And on that topic, that this arrhythmia could occur, that could lead to the heart not functioning, not
pumping well.
Yeah. Then, because we discussed this a couple of days ago, there are certain people who like this idea of, let's go and train together in the pool, and since the dives that we're going to do are very easy, now we just do our dives at the same time. We don't have to provide safety for those dives. And I've always really had a serious problem with this. To be frank, I think it's stupid. Because
it is.
There are just because you're a 150-meter diver in the pool doesn't mean that something is not going to happen. What you might call a black swan event. This arrhythmia or some aneurysm or pneumothorax, whatever it is, could all, so many random factors could occur. So I very strongly discourage people from a personal standpoint not to do any of these no safety dives, just because you think it's very submaximal or very easy.
Yeah, I absolutely agree with you, and I also know of some accidents, lethal accidents, in recreational freediving, where people were confident with doing many 25-meter laps all at the same time, and not good.
Yeah, no, you don't know what's going to happen. I think a lot of people forget that as safe as freediving is when you are with a buddy, the consequences of a blackout when you're not with a buddy can be life-changing.
It's
for people.
very likely it is life-ending.
Yes. Don't forget that, guys. We covered the dive response in detail in the first interview. One of the things I always remembered about that, because I'm still struggling with the education materials from Ida Molchanov, is that I really liked how you said that the spleen contraction was not part of the dive response, which I'm still trying to convince people of.
It doesn't matter what you call it, but I mean, it is completely different response, and it's doing different things. The diving response is conserving oxygen. The spleen response is increasing the oxygen storage, and it is kicking in when you have a first hypoxic event. So when you do serial dives or warm-up, then you need the first dive to really make it happen, and then you have a larger oxygen supply, and then the diving response will kick in after that to try to conserve your oxygen. So it's completely physiologically different.
And something else that I remembered wrongly about that, and also Frank and I had a good discussion about that on the recent interview that we did, but something that I remembered incorrectly about that was that I had thought that it was rising CO2 that stimulated the splenic contraction, which always led me to tell people, another good reason not to hyperventilate then. But you told me that it's mainly hypoxia.
It's mainly hypoxia, and CO2 contributes a little bit, because we have compared also high altitude hypoxia, where you have a very low CO2, with apneic hypoxia. And we see that with apnea, the spleen contracts much more. And then we have done experimental runs where we see that also the hypercapnia is increasing the spleen contraction a little bit. So it will be even stronger toward the end of the apnea when you have the hypercapnia.
Yeah. It sounds to me like what you're saying again is that normal breathing, normal blood pH level before a dive is again optimal for producing all the benefits that we want from the splenic contraction, from the dive response, everything like that.
It's thanks to evolution.
Yeah, thank you, evolution.
I think people evolved to do different things, run and walk and climb, and that includes diving.
Absolutely, yeah. The dive response, is the dive response affected, the strength of the dive response, is it affected by hyperventilation?
No, not much. But when you hyperventilate, you also have to use some oxygen for your respiratory muscles. So actually you start off with a worse situation where you already consume a lot of oxygen if you hyperventilate.
If you're doing the kind of like active hyperventilation that requires you to actively breathe, right? But probably if you're just doing that kind of subconscious, quiet hyperventilation, it's not going to make much of a difference.
Not so much, not as much, I would say.
Okay.
Yeah.
Because in my mind, I thought that that vasoconstriction is going to be the amount of vasoconstriction is going to be important for hemocompensation, especially in the lungs. But that's not the case.
With hyperventilation, explain how you think it would work.
Because then the what would my point be? That that we would need that CO2. I was thinking that the CO2 level was somehow contributing to the extent of vasoconstriction, but that's not connected.
Not so much, I would say.
Okay.
It's only in the extreme situation.
Don't make up your own science, guys. That's the lesson there.
Yeah.
Okay, good. Just to clarify a couple of points on dive response and especially blood shift. It was my belief that the strongest blood shift would be happening, and I'm thinking of blood moving into the capillaries or into the chest around the alveoli, that this would be happening more as we're getting deeper. But this is maybe not the case.
I think the main blood shift happens actually when you go from air into water. So when you put your body in water, when you just jump in the water, that's when most of the blood concentration in your thorax and in your body happens, because then that's when you remove the gravity effects on your tall body when you are standing on land. But then when you hold your breath, you will have the diving response start. That will squeeze in even more blood to your middle of your core. And if you reach depth, it will be enforced even more, because that's when you are actually sucking in blood from your extremities to your chest.
So it's a whole kind
like
of spectrum of
steps.
But what you said there, I think that's a really interesting point for people to understand, is the idea that as soon as you get in the water, you have this redistribution of blood, because gravity is removed from the equation, right?
Exactly.
Most of the time we have blood kind of
pulling in our
trying
legs
to pull
and
down.
feet.
And we are, we the heart keeps the blood moving around so that we don't end up just with a.
And also the temperature change. So it would be 4 factors that focus your blood in your abdomen and in your chest.
Fascinating. Okay, so I cleared up a few points there about the dive response for myself, and I hope that was interesting for everyone else as well. Okay, what's going on with myoglobin? Do we have it? Do some people have more than others? Can we, what is it for a start?
Myoglobin is something that is similar to hemoglobin that is carrying oxygen in our blood. It's the red stuff in our blood. And myoglobin is kind of a local oxygen supply in our muscles. And in terrestrial animals, it's usually considered as just a station to transport oxygen to our mitochondria that are using it. But in marine mammals, it's known that the myoglobin is very, very high. And when they have a strong diving response when they dive, the muscles have their own local oxygen supply, so they can keep in the aerobic part of the dive on their own, so to speak, without having a blood oxygen delivery. And it's not known if humans can accelerate the myoglobin very much, but it has been observed in divers in one study by Anthony Salia that actually it seems like we can have a higher level of myoglobin when we are trained divers. And it has also been seen in high altitude populations that they have higher myoglobin content in their muscles. So that's kind of corresponding, and it's very little done on it. And I actually wanted to do it many years ago. I even had the ethics for it. But to do these studies, you have to actually take a muscle biopsy
which
from
is-
skilled divers. And
Yeah.
most skilled divers, you can find them on competitions, and they absolutely don't have time to be on land after such an sampling
yeah.
for several days.
Yeah, so these muscle biopsies, and if for those who don't know, are quite invasive and painful procedures. You actually,
You can have a local anesthesia, but of course you have a small wound because you need to take out some
Yeah.
muscles
Yeah.
tissue.
yeah,
I don't do it myself. There are
Yeah.
experts that do it,
yeah,
but still, I think it's quite it's a quite important study
mm,
that maybe some really skilled free divers should consider being in, that we can eventually understand if people have the same ability as seals. Seals have 10 times more myoglobin in their muscles than terrestrial animals.
mm. Yeah, that would be fascinating. Maybe grab 10 or 20 elite level free divers in the off season and take them out for a drink and.
No, but if they volunteer to be in the study, if we have 10 of them, I can arrange a study like that.
Mhm. Talking of studies that could be arranged, we also discussed in our pre-conversation for the interview about the effects of caffeine on the dive response and what the possibilities could be there. Thank you for the question from the Patreon supporter. I forget who it was, but thank you for the question. So we obviously, if caffeine is increasing the heart rate, then it could counter the bradycardia that comes with the dive response for sure. It seems like common sense, but there could be some other interesting dynamics going on there between caffeine and the dive response, or caffeine and in diving in general. What kind of study would you conduct? Like, how would you do that if you wanted to find out more?
We could easily find out. I couldn't answer your question. I would say that the basic heart rate would go up a little, but I don't know what the diving response would do actually. Probably the overall heart rate would be a little bit higher, but we could easily do the same kind of study that we did with beetroot juice or with fasting, where you have a weighted design and you have people do static apnea without caffeine or with caffeine, preferably blinded, that you have some decaf coffee or some coffee.
You need some good decaf coffee to fool the coffee drinkers.
And also I think it has to do with who is using caffeine on a regular basis. Because if you read people that are really addicted to caffeine, they might perform worse. So I think this is always a thing that is difficult to determine. But we could do the study here in Dahab if people are interested.
I'm sure a lot of people would be interested in that, because that's one of those things that, a lot of people are unwilling to give up in any sport or any anything that people want to achieve. Coffee is one of the last possibly negative habits that they're unwilling to give
and
up.
And it's
right?
also about the amount, of course.
Yeah,
I mean,
yeah.
if you drink very much coffee all the time, maybe it's a good idea to minimize it a little bit.
Yeah.
But I mean, half a glass of coffee or cup of coffee in the morning before you dive, if you really like it. I think it's psychology as well.
Yeah, I mean, even with that kind of low-level addiction, I think that obviously if you have like a habit of caffeine, even if you're just having like one coffee a day, again, if you're coming towards the peak point in your training block or just before a competition and you suddenly decide to cut out coffee, there might be some rebound. The neurons might not be firing as efficiently in the brain because you skipped your coffee, and maybe it's actually beneficial to control the caffeine intake.
I don't think you should stop just before a competition.
Yeah.
I think you should know what you're doing much ahead of time.
Yeah. And what about alcohol? You said that you already did some study with alcohol.
We had a question from an insurance company if really alcohol is making people drown or if it just makes them fall overboard. Because they found that many people that drowned had alcohol in their blood. And we had a low volume of alcohol for the people, like 1 beer. And we saw that compromises the diving response a lot. So alcohol, for sure, it's making it almost impossible to constrict your vessels to the degree that you save oxygen for your brain. So I think we have shown that. We haven't published it, though it was a student work. I did it 20 years ago or so. But it was quite clear that even a low amount of alcohol, it compromised your diving response.
Because of vasodilation caused by alcohol?
Yes. And something that was funny was that we actually tested, this might come out wrong, but we actually tested that in trained free divers, and this is what I was referring to, but also we trained it in completely novel people that didn't even try to hold their breath before, and they performed better, which is a risk factor in itself, because they didn't listen to the warning signals to stop breath holding. So this is also a kind of bad idea to start breath hold diving when you have some beer.
Maybe that's why the guy in Indonesia held his breath for 4 minutes, because he was so drunk. Didn't get enough warning signals.
Yeah, I mean, also for a competition diver, it's very clear that you perform worse. So the novel person would hold the breath a little bit longer, but the competition diver would hold the breath for shorter time. This is what we saw.
Interesting. Okay, so there was we have this that we put on the table from Pontus.
Yeah. Pontus Holmström.
Pontus Holmström, about the high altitude tolerance.
Yeah.
And there was a question from the Patreon supporter. Who was it now? It was from Peter. Thank you for the question, Peter. Well, we decided not to, because you were asking about some medication. We decided not to discuss pharmacology. That is not really your area. But you did mention some interesting things about high altitude in relation to free diving, and we discussed. I think a lot of people also want to know if high altitude is a good place to train for free diving, if it's beneficial to be at an environment where the partial pressure of oxygen in the atmosphere is lower.
I think high altitude could work as a kind of pre-setting for free diving, for advanced free diving, and the other way around as well. You could train for high altitude by holding your breath, because very many factors are in fact the same when it comes to hypoxia, even though breath holding is like acute hypoxia and the high altitude is chronic hypoxia.
Yeah. I think that was Peter's question. Actually, part of it was that, could you train for high altitude using something like CO2 tables or O2 tables or
O2 tables, I would say. CO2 tables is unnecessary because when you are in high altitude, you have very low CO2 because you need to breathe a lot. But we actually found that you can do an apnea test to determine who is tolerant or not to high altitude. And that shows that inside the body the same things are working when you go to high altitude and when you're diving. And it used to be thought to be completely the opposite things, if you go high or if you go deep. But it seems like you're recruiting the same defense systems in your body.
Both low oxygen situations, right? And then when you say you can use an apnea test for that, would that be like the ramp test? It
would be similar to the ramp test we have done with the maximal apneas, but then we're talking about people that never dive. So people that are going to high altitude, if they get to hold the breath first 1 minute and then 2 maximal breath holds, and then we measure the diving response and the spleen response and the blood response. We can divide them into groups who will be prone to develop high altitude sickness and not. And those that have a strong diving response, they will not have altitude sickness at a given level. I mean, at 4,000 meters or so.
Right. Yeah, because explain again for me what is actually what the adaptation is taking place, because you had this interesting description of the adaptation that takes place when we go to base camp, for example, on Everest, like why we have to stay there for 2 weeks, like what the changes are taking place in the body. You explained very nicely. I can barely speak English right now, so I'm going to do my best to ask this question. But that there's something very interesting happening with CO2. And
well, the first thing when you go to altitude is that you have to breathe more because you get hypoxic, and then you get rid of more CO2. And when you sleep, for instance, at high altitude the first night at 3,000 meters or so, you will have periodic breathing.
Meaning that you sort of stop breathing
you
every so often?
hold your breath, and then you start breathing when you are really hypoxic, and then you have to breathe so much that you go very low in CO2 again, and your brain is set on the CO2 signals to arrange your breathing in a balanced way. But when you adapt to high altitude, you start using more the signals that come from your hypoxic sensors in your blood vessels, and you can just forget about the CO2, and your kidneys will set your pH in your blood right again. So over 2 weeks, you just listen to your hypoxia and not to your hypercapnia. And at high altitude, you will need to breathe more. So it's very important that you can still keep your blood pH at a good level.
So yeah, once again, like another 10 points for evolution, doing an amazing job, even when we go into those extreme environments. But it makes me wonder also maybe you have some thoughts on this. If we take a group of very highly trained freedivers, obviously this is kind of what you've been doing, but if we take a group of very highly trained freedivers and untrained freedivers, how different are they? On a deep level, physiologically, how deep are they? If we compare top level marathon runners, for example, they have very different physiologies than the average person.
I wouldn't say different. I think they have just pushed a few of the systems to the edge. Like with other sports. Right. It's not so specific, I think. But there are other things that are important if you have to be a good runner than if you have to be a good freediver. So I think it has more to do with the level you train, because athletes in other sports as well are really pushing toward a side where they usually have to start with the genetics to develop, and then they train as much as they can and with very specific training methods, and then they can go to the very top level. So I don't think they are different, but they are trained in a different way, and they have different specific characteristics. But it's also not contradicting to be a good runner and to be a good freediver. I don't think.
Yeah, I don't think so either. I mean, I come from a background of long distance running, and I think obviously training for an ultra marathon at a high level is going to contradict the training for the freediving quite,
because you have to train a different thing.
Because you have to spend 20-30 hours a week running around in the hills when you should be diving, right? But at the same time, the benefits of the improved the vascular mobility, the improved heart respiratory function, all of the improved functions of the body that come from this kind of running exercise or cycling or swimming or whatever it is going to be beneficial to your health in general, which is going to be good for your freediving, right?
I'm going to a conference in Belgium in the end of June, together with an anthropologist also that thinks that swimming and diving was a prerequisite for being a good runner, evolutionary speaking. So we have a kind of swim-run hypothesis of human evolution.
Swim-run hypothesis. Well, I didn't learn to swim until I was 34 years old,
right.
And I was running before that, so I don't know where.
But it has to do with how our systems are promoting one thing or the other.
Then I'm going to ask you some fun questions that you can fire off. These are called the desert island questions. I put them into the interview for the Patreon supporters, like a little extra fun thing, and it's just fun. First question before we do that, last question from Tom. He's asking if someone wanted to work in your field of research, what educational pathway would you suggest?
I'm now in sports sciences, but I'm a biologist, so either kind of physiology or biology.
Okay.
I'm running a program that is called Master by Research, where you can do 2-year project in our group in sports physiology now at Sweden University. So if you have a bachelor exam in something like that with physiology in it, then you can apply for that.
Okay.
That would be one way, I mean.
Okay, desert island questions. What is your perfect morning routine? Okay, thank you for answering those questions. Final question, the question we always ask on this show. Why do you free dive?
I free dive because it gives me a lot of calm and pleasure. And I started when I was 13 and I couldn't stop.
Good answer. Have you done much diving when you've been here this time?
Every day, 2 hours, but not deep diving or anything. We dive. We have it's a moorage line somewhere close to where we stay, so we pull down to 15 meters and just float up. I don't do any deep diving now. I have done 100 feet some years ago with Lotta, but I enjoy free diving also in the north of the Scandinavian Sea, ice sea, and in lakes and everywhere.
So you
and I have been enjoying it always.
So you got your own little private mooring out here,
Yep.
down on this side of the bay.
Yeah, we don't even have to put a buoy, you know.
Yeah, we're also get stuck up in the lighthouse area there as free divers. We need to expand out a little bit sometime.
Yeah.
Okay, well, thank you so much for this conversation, Erika. It's really fascinating. I think there's you're one of the very few people doing this research. It means a lot for our community because it's free diving is such a unique sport, but so understudied, and probably will never have the kind of research that we deserve. I think.
No, but it couldn't be done with all the support from all the free divers, and I'm so happy that so many people volunteer to be in our studies, and then we hope that we can give back some understanding of what everyone is doing.
Yeah, there's already been a couple of things here from this conversation that are completely new to me, and also a lot of clarifications I have as an instructor, as a coach. It's very, very useful. So thank you very much, and maybe once we have a few more things to talk about, we can do it again. And let's keep each other informed. Nice talking to you, and dive safe.
Yeah, dive safe. Nice talking to you.
Nice talking to you.